Hello geometry students, my name is Jami Emigh and this video is our discussion on section 9.4, solving right triangles. Solving right triangles, what does that mean? The process of determining the three angles and the three lengths of the three sides of a triangle is called solving the triangle. A right triangle can be solved if we know either the lengths of two sides or if we know the length of one side and the measure of one of the acute angles. Okay, so it's important to know that when you're given a problem that you are asked to solve the right triangle, you need to come up with all of the missing parts. So let's say you're given the lengths of two sides. So let's say this is like a 3 and a 5. Then in your answer, you're going to have to give 3 more parts. You're going to need to give this side length right here, this angle measure right here, and this angle measure right here. So be careful. Sometimes people find one of the parts and stop and don't complete the exercise. I'll show you the second case scenario. If you're given a right triangle and your task is to solve the right triangle, given the length of one side and the measure of one acute angle, so let's make this, let's say you have this angle, side length, and let's say you have this angle, then you will need to find the 3 other parts. This side length, the length of the hypotenuse, or whatever the side not known is, and then the third angle measure. Okay? All right, so solving the right triangle. Make sure you know all 3 side measures and all 3 angle measures. Okay, let's try an example. Solve the right triangle. If needed, round any answers to 1 decimal place. All right, so we are given a right triangle. We know that by this geometric code right here. We are given one of the side lengths. This one right here is 15 linear units. And we are given 1 angle measure. The measure of angle A is 32 degrees. All right, so based on just that information, we should be able to find all the other missing parts. Now be careful, I see that A and C are labeled there, but the measure of angle B, there's not like a variable there. So make sure you find all 3 of those parts, 1, 2, and 3. And it doesn't matter which order, just go with whichever one you can find first. So I know that I'm going to go for angles, or for the hypotenuse length first. So I'm going to circle my 32 degrees. I'm going to draw 1 arrow to the 15 and 1 arrow to the hypotenuse. All right, I'm going to label this 15 with a lowercase a for adjacent. Maybe, you know what, I'll write ADJ just so it doesn't get confused with that lowercase a on the side length there. And then this one is the hypotenuse, HYP. All right, what is the trigonomic function that involves adjacent and hypotenuse? Well, this might help you. The trigonomic function that involves adjacent and hypotenuse is cosine. So our equation with an unknown in it would be cosine of 32 degrees is equivalent to the length of the adjacent side over the length of the hypotenuse, my goodness. So that is cosine of 32 degrees is equal to 15 over C. All right, so we have our equation written, and now we want to solve for the variable. Remember, the only variable in this equation is the lowercase c. COS is short for cosine, which is a function, not a variable. Okay, how are we going to solve for that c right there? Well, it is stuck underneath a fraction, so to get it out from under that fraction, we're going to multiply both sides of the equation by c. That way it'll no longer be the denominator. And that will look like this here. C times cosine of 32 degrees is now equal to just 15. All right, we need to make another move. Do something to both sides of the equal sign to isolate C. Okay, C is attached to cosine of 32 degrees with the operation right there called multiplication. Whenever you want to get rid of something that's multiplied, you have to use its inverse operation, which is division. Okay, so let me show you what that looks like, and then I'll point out why it's not the inverse. Erase my scratch work here. Okay, so it's going to look like this. Divided by cosine of 32 degrees divided by cosine of 32 degrees. And these are going to cancel, and we'll just have C equals. All right, so some of you might be thinking, well, I thought to move cosine, I had to use cosine inverse. You are correct. To move just the function, just cosine, you have to use cosine inverse. However, we are not just moving cosine here. We are moving cosine of 32 degrees. If you're trying to move cosine of 32 degrees, then you need to divide by cosine of 32 degrees. Okay, so you guys are going to need to remember that. When you're manipulating your equation to isolate the unknown, you can move regular cosine without an angle measure by using cosine inverse. And if you have cosine of and an angle measure, then you need to divide by that. All right. So that will look like C is equivalent to 15 over cosine of 32 degrees. And that would be the exact value. So we're going to go ahead and pick up our calculators, type that in. Okay, so you're typing in 15, division sign, cosine key, 32, close parentheses, enter, 17.687, and so on. Rounding to one decimal place, the side length of C, or the hypotenuse, is approximately 17.7 linear units. All right, so we found one piece. We still have two more to go. It's really up to you which one you want to go with next. I will go ahead and find the measure of angle B next. And I'm not going to use trigonometry to do that. I'll use the triangle angle sum theorem that says that all the interior angles of a triangle sum to 180 degrees. So that would give me 32 degrees plus 90 more plus my measure of angle B has to equal 180 degrees. So that's 90, that's 122 plus the measure of angle B equals 180. So subtracting 122 from both sides, that will give us the measure of angle B is 58 degrees. I'm going to erase that work. It's taking up too much space. So we've got 58 degrees here. We've got 17.7 units there. All right, so we just have one more missing part, and that is this side length, segment BC, which we're going to use lowercase a to try and find it. All right, to find that missing side length A, let's go ahead and use the 32-degree angle again. Now we're going to draw two arrows, okay? One has got to go to our unknown A, and that's going to be the opposite side. Now, careful in your second arrow selection. You have the hypotenuse length. We also have B equals 15, that side length. But the hypotenuse length was approximated to one decimal place. So I'm going to use the 15. And that would be our adjacent side. All right, opposite and adjacent. Which trigonometric function deals with opposite and adjacent? If you said tangent, you got it right. So we would write that equation, tangent of 32 degrees is equal to A over 15. Okay, we need to solve for A, so we'll multiply both sides by 15, giving us 15 tangent 32 degrees for A. And then we will type that into our calculators. Type 15 tangent 32, run that, and that gives us A is approximately 9.4 linear units. And erasing all my scratch work here to get them all. Let's see, we've got measure of angle B being 58 degrees, got that. We got A is approximately 9.4 units, got that. And I'm just reading the bottom here. C is approximately 17.7 units. Okay, so we have officially solved the triangle. We know all three side lengths and we know all three angle measures. Okay, I want you to go ahead and pause this video and try to solve this right triangle. Welcome back. Let's see how you did. Remember, this is just one route. You could have used trigonometry or different theorems, but the route I used is the work you're going to see. But as long as we didn't make any errors, we'll get to the same answer. So I went ahead and used the Pythagorean theorem to find the length of the hypotenuse, and that is approximately 10.3. So if you found your hypotenuse to be 10.3 approximate units, then you got it right. Nice job. Then I used tangent from the measure of angle D. I was trying to find angle D next, and I used tangent because I have the opposite and the adjacent. So tangent of angle D is 9 over 5. Now this we would use tangent inverse, and I found the measure of angle D to be approximately 60.9 degrees. And then for the measure of angle E, if you got approximately 29.1 degrees, then you got that one right as well. So like I said, it's okay if you went about this a little differently. We have quite a few tools now to find missing pieces to triangles. We have Pythagorean theorem, triangle angle sum theorem, special triangles, trigonometric functions. And so if you got the same as the labels I have here, then nice work. And we have officially solved that triangle. Let's talk about angles of elevation and angles of depression. Many applications of right triangle trigonometry involve the angle made with an imaginary horizontal line. So like if you're just looking straight forward, just wherever you are right now, just look straight forward. If I was to put a dashed line on your line of sight, that's that imaginary horizontal line. It's one way to get it. An angle formed by a horizontal line and then the line of sight to an object that is above that horizontal line, that would be called an angle of elevation, okay? So look forward one more time. Just go ahead and look forward. Pretend your line of sight, that's your horizontal line, okay? And then just look up at anything, okay? The line of sight now, you have two rays formed, that horizontal line and the one of you looking up. So that would be considered an angle of elevation. The angle formed by that horizontal line of sight to an object below would be called an angle of depression. Okay, so if you're just looking forward, that's your horizontal line. Go ahead and look down at anything. The angle formed by those two rays would be an angle of depression. Transits are instruments used to measure such angles, and they're going to help us like here. All right, angles of elevation and depression. So let's pretend this is you, and you have that line of sight, that horizontal imaginary line. And if you look up at an airplane, then this angle that you've created is an angle of elevation. And if you look down, say at a car, then this angle that you've created is an angle of depression. Okay, so hopefully you're picking up on the difference between an angle of elevation and an angle of depression. Remember, they both have one horizontal ray or side. Okay, let's practice identifying angles of elevation and depression. What is a description of the angle as it relates to the situation shown? All right, so look at our figure here. Got a lot going on. A bird, a balloon, a mountain, grass, sky. Okay, angle 1. Angle 1 is right here. And would you call angle 1 an angle of elevation or depression? If you said depression, you got it right. You want to focus on the horizontal line, and then the other side of the angle is below that, making it an angle of depression. Try angle 4. If you said angle of elevation, you got it right. Angle 4 is right here. You want to focus on the horizontal line, and then the other side of that angle is above the horizontal line, and that's what makes it an angle of elevation. Okay, sighting the top of a building, a surveyor measured the angle of elevation to be 22 degrees using that instrument we talked about, the transit that measures angle measures. That is 5 feet tall and 300 feet from the building. Okay, so the transit's right here. It's 5 feet tall and 300 feet away from the building. 2 easy measures to obtain, 300 feet away from the building, and the instrument is 5 feet tall. Okay, find the building's height to the nearest whole foot. Okay, so we're being asked to find the height of the building right here, which we can represent by A, and then don't forget to add that additional 5 feet, okay? So we have a right triangle here, and we know 2 parts of it. We know that this is 300 feet, and we know that this angle of elevation is 22 degrees. And that's all we need to know. We can use trigonometric functions to find the missing parts, and the strategy will be to find this missing part, this side right here represented by A, and then add 5 feet to it, and we'll have the height of the building. All right, let's give it a try. I like to, as you guys know, circle the angle and then draw my 2 lines. The hypotenuse wouldn't come into play. It'd be the opposite side and the adjacent side. So which trigonometric function involves the opposite and adjacent sides? If you said tangent, you got it right. So you would set up your equation as tangent of 22 degrees is equal to A over 300. One step to solve this equation, just multiply both sides by 300. And we have A is equal to 300 tangent 22 degrees. If we type that in our calculator, rounding to the nearest whole foot, we get 121 feet. And don't forget to add the height of the part of the building above the transit is approximately 121 feet, which means that our building is approximately 126 feet tall. Right? Pretty powerful to be able to measure the height of this building by just having your one instrument, the transit, and knowing that you've walked 300 feet away from the building. All right, I'd like you to pause this video and give this one a try. Welcome back. Let's see how you did. If you set up your equation as tangent of angle A equals 21 over 25, that is an accurate equation. There are others you could have used, but if you went with that one, nice equation there. Solving for A by doing tangent inverse of both sides of your equal sign, and typing in tangent inverse 21 over 25, approximating to the nearest degree would tell us that angle A is approximately 40 degrees. The other equation you could have used, it takes one extra step, but if you went from angle B, that would have been tangent of angle B is equal to, and then it'd be 25 over 21. You would do tangent inverse of both sides. You would have angle B equals tangent inverse 25 over 21. You would get that measure to be, see, it's going to have to be 50 degrees. Not even using my calculator there. I know they have to sum to 180. So that would be approximately 50, and then you could use the triangle angle sum theorem to find the measure of angle A. So if you accidentally went from angle B, just one extra step, triangle angle sum theorem, and you'll have your measure of angle A. And that will conclude our discussion on Chapter 9. My name is Jami Emigh. Thank you for joining me, and I will see you next time for our discussion on Chapter 10.